Saturday Arnold Cafe. I guess we're open for questions. I had initially planned that I wanted to prepare some stuff. I did that the first two times, but I actually think I just want to go with the flow this time, and let's see if we get some questions. The stream has been on for about 4 minutes or so, and I was just tinkering with some tune I have I made or I am making. Um, so actually, today we start way on the floor. I will have absolutely nothing to show. Perhaps I will show one thing in a moment. But otherwise, we'll just see if we get some questions going. Uh, so I'll return in a bit. Okay, so we're back. I just had to get something to eat, so I grabbed a banana. Let me wipe my glasses here so I can see what I'm doing. So until we get some questions going, I think I'll just resort to show some OSL coding, some OSL effects, some shader stuff going. So let's see here. I have something here. It's a scene called Flotteting. Flotteting in Danish means beautiful things or a beautiful thing. Um, so um, so let's see here. What is this? I have a noise map here. I have an Osl UV transform. What I did here is that I changed the initial input to P. If you bring out a normal one, you will see that you will see that the UV transform comes with a U and V coordinate here. This is a point where the third dimension is left out, so it's basically just referring to a normal 2D texture. So I expanded that into the P component, which is X, Y, and Z, a volume shader, basically. So that's just, so this node here is actually custom. I pulled it out and changed the point to a P. So, and then we have some kind of shader I pulled off from an online repository, originally written in Webgl. I changed it. I had to include some vector 2 components, vector 4 components. We can delete these and upgrade the shader code down here. So this is just a typical Webgl to Osl conversion. I'll show you some interesting stuff here. Get it moving. So I'm going to go into this mode here, and let's try and check here. Okay, it's chopping. Actually, it's chopping because I have a thumbnail rendering down here. So you can see here, chomp, it stops. So once you disable that, the construct starts to or drops the penalty from rendering the thumbnail. So let's see here. What can we do here? Well, these are obviously just UI entries I made into the shader. Let me see here. So those, basically these guys down here, that's between this one and this one. All this is mapped to the UI. The point is in the bottom here, but you can see there's a time float, mouse, holes, TT, grow, effects, thickness, detail, iterations. So let's try and play a little bit with this one. Let's see here. So this is an internal scale. You can see here we can scale this thing up. And one thing I should mention, that this is actually right now, this is just a shader on a plane, as you can see here, but we can map that out to a volume shader or the Arnold implicit node. Let me just go out here, go to Arnold. You have the implicit node here, and the implicit node is one that is shipping with the Rebel pack construct. The Rebel pack includes scene converter items here. You can see here we have some legacy bitmap to Osl Bitmap. We have Corona normal map to Arnold normal map. Corona sky to Arnold sky, and all kinds of things you can convert. V-ray color to empty color, and you can basically use this construct. The Rebel pack will come with all these files here, and it will make it possible to change or translate your V-ray and Corona scenes a lot easier. Instead of having to manually convert the shader nodes and the materials, you can get up and running with this one. And just to show how easy it is, let me see here. If we go something like this, remove all these rules. So now there's no rules. I get a lot of questions about the preset, what you actually want to do. Just take the Corona sky there, Arnold sky, and pop that into there. Okay, and you can then save this out to your own preset file. So, and if you want the legacy checker to convert to the OSL checker, you basically just add them. So that's it. That's what the actual preset file is. My website, I'm going to update my website. The Arnold converter is going to be continue to be called or named Arnold Converter. Um, but I will host it, and it is hosted in something I call the Rebel Pack. The Rebel Pack includes both the same converter rules. I have a lot of requests, new requests that goes into that, and but this implicit node here will is also part of the Rebel Pack. It makes it possible to render things like this noise map here, OSL noise map, as a hard surface, but with virtually zero memory penalty. So you can go far beyond what a normal displacement. It also projects and prints a vector displacement instead of normal displacement, so you can make a lot of curly and double folding things, and you can make these kind of constructs here, and you can just keep shoving in details, and you won't have any penalty on the memory side because it's actually treated as a shader. So that's a very powerful thing. We can try and open up the implicit a little bit after this one. And this implicit node here comes pre-installed in the Rebel Pack as well. And there are some nice scripts I made that also made it into the Rebel Pack. So let's just move this one on the side here. Let's go back here. Let me go here. Something like this. Let this run. So so let's see here some of the features here. The scroll thing. So, and what you can do is it's currently mapped to a sphere inside the shader. We could pull that out to the implicit node I showed, but you can also express this as a volume density, and map the colors out as well, of course. The gradient right now is looping between red, green, and blue from the center and out, and we'll keep iterating or repeating that till infinity. So as you can see here, this is the max viewport, so showing that the max viewport is actually able to convert these OSL things to what the viewport, the language the viewport talks in, which is HLSL. It's a similar language like GLSL. Those three languages are roughly the same. 3 Studio Max viewport is HLSL. So, and it can take the OSL code and print it. Let's see here if I can hit 7 here. Let me see here. Yeah, it's running right now. It's capping at 30-40 FPS. That's pretty decent. So let's try and shrink this follow down again to something like this. What is fx? Fx is some kind of density parameter. We still get the local booleans, but we can shrink and increase these cell-like patterns. And we have the thickness here. And this is the detail amount. I think detail and fx is actually the same thing I mapped out. So that's it. And of course you can always do something like this. Have a little bit of fun. Take a noise. This is an OSL noise. uPerlin. Put that into any of these, And since the noise is a float, it works in world space. It means it reacts probably to the code inside this shader, which is also working in world space. So we can see here that one wasn't too desirable. We have the time variable. So basically, what you want to do if you want to have something like this continue moving, rotating, you would add it up to an actual time increment. The time, as you can see down here, it's running. This is actually a float value. It's an integer, but it's a float value, and you want to add it up to this one. You can see here this value here. It keeps incrementing, and you want to add it up instead of bypassing it. Otherwise, you will just get some morphing in the domain here. Let's see here if we can find some interesting some of the thickness, something like this. This is some kind of interesting result of this particular effect, and we could start working with the scale of this one. Let's see here. 1. So that's what I do. Normally I just plug things in. It's not very scientific, but often you get a lot of interesting results when you don't use the brains too much. You just sit and plug things in and watch for interesting tendencies. Something like this looks kind of nice up here. So yeah. So maybe we should go to the next related item. I can pop out of this one. That was the implicit node, and I can show you here the Rebel pack that I'm shipping with the scene converter stuff and the implicit. Actually also installs a new entry in the Osl shaders here called Rebel pack, and we have some different maps here that I wrote. Flow map, we have a flipbook map, flakes, I think I showed that last time. I have a field scatter here, some different things. I have a new composite because the one that ships with the 3D Studio Max is it's not broken, but it's incomplete, so there's some errors in it, so I made a new one here. So and inside the Rebel pack we have a subfolder called SDF. So those are actually shaders that are already prepared to be working on this implicit node. So let me go here. Let me just check something here. Just 2 seconds. Okay. So what were we doing? Okay. So let's try and bring out this implicit node here. So actually, I'm going to shrink this one down considerably because we have a bug currently in Arnold with this. We have to work in very small scale. Something like this. We don't need this one. We don't need this one. We actually don't need this one. Let's take a new a new noise here. We could take the 3D noise here, and as you can see, the implicit node has a map input. Let's open the render view here, and need to disable step function. I need to let's see here, is it the noise instead? Need to stop this one, start it. I'm not so sure why this is not. Oh. Not so sure why it's not working. So this is trench work. It's prone to crash, and sometimes it doesn't work. Need to check here why we don't get anything. So we have the noise here. Oh, we need to change to Perlin. Something like this. Why are we still not getting anything? None. Exposure. Why am I not getting anything here? Uniform. Okay, there we start to get something. Okay, let me scale this one down considerably. Oh, something like this. So, and this is actually a hard surface. We can verify by adding a physical material to it, for example. Let's do that. Something like this. I think it's slightly overexposed. Something like that. Let me see here. Can I move this back to the SDF? Yes, I can. So we start to see some stuff coming in here. Let me put this one down there and plug in an Arnold light, skylight 0. Let me add up to X here. Maybe we want to speed this up a bit. So 3 is too high. Something like this. Something like that, yes, that would work. So let me just crunch this guy down here. Something like this. And as you can see here, this is just a box. This is the bounding box of this solid here. So if you wanted to make a mesh with a normal box, let me see here, standard, like this one. If you wanted to start and build something like this, good luck. You will run out of memory so fast. Because you won't be able to capture it with a vertex array. All these guys here defining what the box is, and if we try and go in here, do something like this, we obviously increased this object's vertex count, and we can keep do that and try and do something like this. But at one point you will break down fundamentally when you work with the concept of vertices and arrays. It will become slower and slower and slower and heavier, and in the end, you won't be able to match what we can produce with the implicit node. So you could think of this as some kind of coral or mountainside. We can of course change this by changing the noise here, changing the settings down here, multiplying noises using different kind. Sorry, 2 seconds. Multiplying noises, and I have a bunch of research shaders that will make these implicit surfaces look crazy spectacular. We can try and pop up something like just moving on my secondary monitor here. Let's go here. I'll pull this in when I find it on my channel. People post, so there's a lot of posts here. So, and we'll be able to make something like this, and this is actually a hard surface. So you won't be able to do this with, look at this nice little detail stuff we got here. This is of course all procedural. You won't be able to do this with vertex areas because your machine will break down, and you can try and buy the best and biggest, you will break down 100%. End of story. So that's one of the more sexy things about using implicit nodes or Arnold implicit, because you can just keep adding details, and you will spend kilobytes of memory instead of gigabytes. So it's actually the reverse expression of the heavy old traditional version. You won't be able to break it. So this is actually SAP's. This is actually a derivative of one of SAP's noises. Let's see here. Let's see here. It's this Uber noise here. 2 seconds. It's the Uber noise, and I made some changes to the code, so we can inject custom shapes. What do I mean by custom shapes? I mean things that we have up here, like a box frame, a cap torus, a sphere, torus. These are the initial shapes, and we can scatter those out in space, and we can make hundreds of billions of spheres or toruses that looks like this displaced, and it will still only fill a couple of kilobytes. So of course you can't do that. You can't do that with something like Forest Pack. You can't do that with V-Ray scatter. You can't do it with, if you work in Maya, you use something like a Bifront scatter or whatever. You can't do it. You will not be able to get the same amount of instances. You won't even be able to get 1,000th of the amount of instances you can make when you work with the implicit node. The only catch is you can't take some leaf or grass or plant or something like this and shove it into this equation yet. There's some research going on about this called Cyrene. It's an AI. It's actually a girl that is researching it, which I find it quite impressive. I tried to run it in 3D Studio Max. It is actually making a very good attempt at taking meshes, something like the teapot, and making an implicit model of it by multiplying a lot of matrices. That's actually it's storing the points in matrices that's getting multiplied over and over and over until the form starts to the detail starts to shape up, and you actually let some AI generate these matrices. And these matrices we can shove into Osl and let it run. And once it runs in there, we can take the normal 3D Studio Max model and shove it into this realm and get rid of all the huge penalties from things like forest pack introduced, because you can't put in 1 trillion trees or 100 trillion trees in forest pack on a 60 gigabyte system. I doubt you can do it with a 250 gigabyte system. It will break. But if we go through this route, we can do it on 1 gigabyte machine very easily. So this is kind of like the front edge of implicits and SDF, some of the possibilities in this. It's very, very powerful. You can't compare. It's not just a lot better than traditional scattering or modeling. It's way beyond that. So that's why I spend a lot of time on it. I think it's very interesting. But back to the Übernoise here. We have I actually use SAP's map because the Übernoise, as it is incapable of rendering something like this. So I injected a little bit of code, and it's actually up here in these 3 for loops here. I inject some code up here that intercepts the point signal and returns a simple box. So this is actually a simple box, just a square. We will let run through some iterative sequences, and it returns something like this. Let me move this one over here. Hello, Mahesh, Mai. Good evening to you too. I hope you have a nice evening in India. I'm sitting in Denmark, so right now it's 18:33 here. So yeah, so these kind of interesting things here can go to displacement and scattering, and I will reveal more of that in my Rebel pack. So this section here will keep expanding. There will be some unions, some subtractions, some Boolean nodes. You can build some interesting things instead of using a regular mesh. Obviously, you are compromised because you can't just model something nice and shove it into this realm. This is where this Cyrene project comes in, and over time we have to figure out a way to shove normal mesh into matrices instead of vertex arrays. But there's some research going on in the 3D community, not just 3D Studio Max, but just in general rendering and real-time expressions, AI, and of course I try to do my best to integrate whatever I can into 3D Studio Max when I get some breakthroughs on these accounts. because I think it truly is awesome that you can render things that are super detailed at no penalty, at no cost at all. Um, so let me just see here. So this is our noise. We can go down here. This is just one octave, and 2, 3, 4, 5, 6, 7. So you would, if you did a normal displacement, you know, you have on your subdevs, you have subdevs level 1, 2, 3, 4, 5, 6, and the more you put in, the heavier it gets to render this. But just check at the refresh rate. It's instant. It doesn't care. It doesn't care about the iteration amount. So this is why it's far beyond regular displacement. You will never do this with traditional modeling. It's simply too the technique is simply too powerful. Um, so so that's nice. We can try and lower this one. See what this one does. Something like this. So this is the general concept of working with implicits, and normally you're restricted to this kind of domain with a standard volume. Most engines work with this. Like we could also make a fog or a cloud. Um, but what people runs into of difficulties is to implement a reflective curve on this surface here. Like if we put an HDRI, it would reflect in this one. It would reflect the environment, and we could also make it into a glass. So just think about making something like this as a glass piece or a mesh, a regular mesh. Look at all these small details we have down here and up here and all this. This would be incredibly heavy for the machine to calculate and update. And here we go, like this is nothing. This is nothing for the machine to calculate. So that's why I find it very interesting. So that was the implicit node. Let's try and see if we can jack up some of these nodes down here. So we had this box here. This is actually just a domain. It's not a box, so we can take this torus here. Let me delete this one. Let me keep this one. Delete this one. Something like this. And you can see here we have a torus. And I'm actually able to replicate this one 600 billion times, and we wouldn't be able to track the memory consumption. So that's quite powerful. Let's try and go here, take something like this. Something like this. Oh, was that transparency just up? I think it was. I'm going to here. It was the metalness I wanted to pump up. Something like this. And as you can see, the sky is reflecting. I'm not so sure, I like, there's something I don't like here. What is it I don't like? I don't like the double thing here. So I'm doing like this instead. Okay. So we have our torus here. This is not This is not this torus here. This is very big because my scene is very small, so I'm going to go like this. Just quickly go here. I have a cat that is whining in the background, if you can hear that. So it's not this torus. This torus here. It's expressed mathematically, and that's why we can scatter 600 billion of them effortlessly. Um, we can actually also model grass straws. We can model patches of grass, and I'm going to do that. I'm going to create some initial assets for grass straws, bent grass, different types of grasses, and we will be able to challenge Corona scatter, V-Ray scatter, forest pack. We can crush them 100%. They will not be able to match this with vast amount of detail or amounts of instances, and we can map their position to actual geometry because we can pass in external geometry. We can interpret that as a position in space. So this point is where it's becoming a little bit of challenge, because with regular scattering you have conveniency of using actual mesh, and they code these things in C++, and you can hook things up in a trivial way this way. But you have all the penalties of working with arrays, which they will never be able to overcome. So that's a hurdle. I need to find out how we can do this without increasing the entropy too much. That means wiring up things and doing crisscrosses and hacking, but return a simple as possible expression as possible for the end user, because normal user generally just want to go in and you can see here, go in and push a couple of buttons and get on the way. So you can see here there's a hole now in this torus, and it's because torus is now exceeding this domain here. So what you wanted to do, if you wanted to do something, is you want to actually just scale it down. So and make it thicker. So these are some of the things. Let me see here. We have this one. So let's see here. How's this going? Rotation is not going. Oh, I think this is one of, actually I have a newer version of this one. Let me see here. Yes, it's rotating on this one. So I fixed the Y component. And you can move these things around here, and as you can see, we are not using the this one. We're actually using something directly inside the shader here. So that's a different way of working. You have to think in shader space for now before these things makes much sense. But I promise once I get some grass going, I will show you something absolutely spectacular with no memory used. I'm not sure why this one is freaking out. Something like this. So we have that one, and we have a sphere. We can take a box. We can try my boxed frame here. So just pull that one down there. Let's see here. See if we can bring it up. So these things are very much work in progress. I don't remember where I put it last. This may be. Oh, this may not be working. Let's see here. So we take the input. Okay. Okay. I think I need to put in a transform here. I think I need to go in here, and I'm not sure about this. It's been a while since I worked on it. Let's see here. It's because we don't have anything there. No, so I think this is not working right now. Dimensions, no, I don't think so. I think it's broken. Let me see here. Oh, okay, I think I know why. I think it's because there's a glitch regarding Arnold here. So let's see here. Where's my torus? The torus is working. Something like this. Why is this one not working? That was kinda interesting why it's not working. It should be working. Well, I shouldn't be sitting and filling the stream with broken code. So I think I'll just move on, but something tells me something fundamental is broken here. But it was good that the torus worked, so I could get you some of the first looks into this, because I'll show you things that are beyond spectacular with this. That's for sure. We can pick up challenges from I2 and whoever on the stream real time. We can split screen with them, and I will crush them. We will crush them 100%. So I'm that confident. So that's it for the implicit. And as I said, this node is accessible. Actually, SAP wrote this one, but I did all the other stuff. Just made an interface for this. So full credit to SAP for that. But actually, it's the implicit node is publicly accessible for anyone. You just need to do a little bit of scripting, and it should be fine. Actually, now I see that this box is not centered. Was that it? It's not working in world space. So I think something was broken. So reset. So I'm very much looking forward to show you more in that regard, and to get that ball rolling, because it's quite spectacular. We can make a plane eventually, give it some noise here. Raise it up a bit, something like this. Let me see here. So we can do something like let me remove the grid. We can do something like this, and we can actually steal information from this plane to all those grass straws, and we can make 600 billion grass straws, and you will not be able to measure it on the system's memory consumption. And if you change the layout, if you use a map to drive certain strands or hairs, it will be instant. It will not require some recalculation, some slow array need to update. It will work just as fast as I changed the the noises iteration amount. This one down here, octaves. He calls it octaves. So that's kind of interesting. I will show more of this later on, and of course, always, if you have any questions about OSL, please come over to our group here. We have 2,800 people. I started with inviting 2 people. I said it was fine if we were 10, but now we are a little bit more than 10. So that's cool, and we have 2 Class A administrators. Larry was kind enough. He is actually the grandfather of OSL. It's actually his project. He wanted to be an admin, and we have SAP. He is the all max implementation, all random rendering freaking guy. He knows his stuff, and I'm there, and I occasionally I pop in, and I try to help people if I can. You can see here something like this. Some guy here. He had a question. Does anyone know? This is actually for Octane for Cinema 4D. So that's one thing that this group here has in common. It's not just 3D Studio Max. We're actually focused in on OSL. Wherever OSL is located in our industry. That could be Houdini, that could be Maya, 3D Studio Max, and we occasionally get some questions from Cinema 4D. That's fine. And other render engines, of course. Autodesk. I'm Arnold. Personally, I'm Arnold biased. I prefer to use Arnold, but that doesn't mean we can't help this guy here just because he uses Octane. So he wanted to basically he wanted to have some kind of OSL shader that would randomly rotate some image 90 degrees in all on his instances. So we went a bit back and forth, and SAP actually mentioned here that you can use one of the maps he wrote, randomized bitmap can do this. It's completely true, from 0 to 270, and use 4 steps. I also provided a solution here. So these are instances. The image is this water and this sky here, and if you just make some instances of a plane, it will randomly rotate them, but only 90 degrees or 180 to 70 or 0. And the way you do that, sorry, 2 seconds, is to either use some of SAP's base nodes here. You grab the hash of the items. The hash is actually you can sort of like look at it as an ID. It's a unique number of value for each of these planes here. And we use that, and we use random by index. That means we shuffle it around. We basically press the shuffle button and use that as a driver on one of n float, because it's a float value. This is a float. A float value is just a random number, single random number. And I put in the stuff that Saps mentioned, 0, 90, 180, and 270, and 4 ticks. I just push those into the 4 slots here, 3 slots here. Pipe that to a rotate on a UV transform, because that is in radians, so 0 to 360, and pipe that up to the UV coordinate of a bitmap, and pipe that into a physical material, and we basically have it. So, but instead of doing that, or use SAP's thing there, he actually asks for a script, single script. So I thought, what the heck, let's just do it. So I condensed the map we have up here, or these maps. I just took the relevant code for all these 2, 3, 4, 5 nodes and put into one single map that does the same thing. So let's try and go to the code here. Let me go up here, select my own code. I'm stealing my own code here because I didn't save it. I have a good/bad habit of deleting everything I do. I always delete everything I do, almost always. If I sit and code on something, or if I have a test scene or something, it goes on the desktop, and I just 9 out of 10 times I just delete everything. So I don't have this code anymore. So that's why I had to steal it from myself. So let's delete this one. And when I make, that's just me. When I make a new map, it always have to be the checker map here. I always, if I have to edit something, start a new shader, and this should compile. If I go like this, shader, we need a name here, something like this. I always have to start with the checker. It's just something that I do. So we paste the code in from the paste bin, and it compiled, and we now have this one here. We take the physical map like this, and so we need a texture. Let's see if I still have. No, I have. Yeah, I have. Let's see here. Let's see here. What's this? Okay, this is the funny crap thing. So I think, I don't remember who it was, but someone on Facebook liked an image, and it's some kind of let me remove that. And it's jazz scraps. It makes no sense, but I think it's funny. So let me go like here and make a bunch of instances. And as you can see already, it starts to randomly rotate all these fellas here. Something like this. So we have a ton of jazz scraps here. So and this is basically what the guy over here, he basically, I believe this is what he wanted. He did not return. He said he wanted to try it. My only condition was that provided Cinema 4D and I don't know, this is the only cliffhanger, but it should be using I'll be able to fetch the get attribute. I'll explain that, what that is. Basically, we're fetching the node name and provided those Octane guys. Octane is also for 3D Studio Max. Provided that is working, he should be good to go. So, and let me scroll up here. Okay, so basically the thing is that I was a bit unsure about, it was this one, because this is a node name, is a special thing that the coders need to support, and I believe they do. And we get attribute node name. This is the hash that you saw. We stick it into a string called a, and we generate an integer value. That's a value like 1, 2, 3, a full number, and we scramble it. You can basically, if you have some kind of value, it can be a string. A string is like letters or numbers in letters. Numbers can also be letters or a string, or just letters. But this hash here is basically equals scramble. It's just random. So now we have a random value, integer value, and we create a shuffle and a range. We create the shuffle. This is a float, an integer, a full number, or a float is sort of like the same thing. A float can be 1.23. An integer can only be either 1 or 2, but a float can also be 1 and 2. So yeah, it's just you remove the everything behind the point, and it's an integer. So we create a float here. So basically, the start point here of this whole shader here is actually this get attribute node name a. We create a string, we load the node name to this string, and we scramble the string and we turn it into an integer. So after that, we make a float. We call a noise a cell noise. A cell noise is basically the same thing as a hash, just up in visible space, and it's actually blocks. It's think of it as a random checker tile. Yeah. So and we load in this integer, an absolute value. The whole thing here is a vector, and we have an absolute value of seed. This is that means that if we potentially have apps means if we potentially have negative values, it will put a plus in front, and then the 42 here is that's a universal number. We could have put something else. It doesn't matter. It's basically octave. No, not octaves. It's the shuffle. It's the internal noise shuffle value. So I just put 42 in there. This basically generates a float that is random in a cell structure, and we this is really coder names R and RR. My coder names could call them anything, and we make a reference frame for this R within 0 and 40. So that means that if I wrote 400 here, we would now have a range of between 0 and 400 of this scrambled string turned into an integer inside a noise self function. So we have this R&R, and yeah, very bad naming policy I have there. So we have that's what I did. I made an if statement here and 3 else if. So that means that I'm attempting to split up all the values, all the random values between 0 and 40 into 0 to 10, 10 to 20, 20 to 30, 30 to 40. And check for those. That's actually what we do with the if statement here. If RR is larger than 0 and RR is less than 10, RR should be 0. So this is actually our rotation amounts. We are starting to generate our rotation amounts in radians. So 0 and 90. So that means if this float value, if we get a float value, hit value up here on this tile, that is 5.6334. This if statement is catching it and saying, okay, I don't care about that. Just make the R here, just make it RR, just make it 0. That means no rotation. Else if 10 between 20, 20 between 30, 30 between 40, and we have 90, 180, 270. That means we have 4 cases of a hit probability for this float RR up here within the range of 0 to 40. So we now have a filter, an RR filter here, or RR is filtered with 4 conditions. And it's time to inject this into the rotation. We create a rotation center, rotation offset, and axis, of course. So this is the c-axis, and 0.5, 0.5. That means that the map up here is going to rotate around this center here and not the corner down here. If we left out this RC here and put 0, 0, it would rotate around this and we will get black. But it will still rotate 90, 180, 270. Oh, I haven't checked this one for a while. Oh, hello Petros. Hope you're doing fine. So where were we? So we set up the rotation center, which we fetched the axis here, and we have a UV. This is the first time we call the UV, and as you can see up here, we generate the point UV up in this init section here, along with the string A. We already explained that. We could also put in P here. That's for position in world space. That means we could actually start to turn it on the C-axis inside the shader as well. So you could start to get some parallaxing going and whatever stuff like that. But we only need to work on the X and Y coordinate. So that is fine. We don't need the last one. So we just, since we in Osl, once you have established that UV is a point, we can just call this UV instead of writing point down here. Actually, if we do that, we'll get a syntax error, or it's stated down here, line 35, UV already declared. So we have declared that this is a point, so we don't need or we can't. Sorry, we can't do that. And we set up a typical rotation of what we want to rotate the UV with what, and we want to rotate it with these four values here: 0, 90, 180 to 70 in radians, based on the center and the axis. And finally, we load a texture and we load the UV. So that means we have an out here. Out. This is our output. That means it's this slot here. This slot here is generated by this line up here, because everything between this guy and this guy is UI. So you can see there's consistency. Text seed out. Text seed out. I hope that makes sense. So what is it that we want to shove into the output? Well, we want to shove in texture. We want to shove in specifically the string text up here, and leaving these two here. We need this. These two guys here. That actually means that it's empty. We could also go something like this, and it would always print that into the string field here. So this is just basically, this is a string. It's the same down here, down here. But since we just want to call a bitmap, we just leave it empty here, and we have a small string widget. I want to show you this. Let me remove this part here and compile it, and watch this one should disappear. So that's actually a component of the OSL 3D Studio Max implementation. This is, I think this is part of the standard OSL implementation. I'm quite sure. So all the other render engines have to support these metadata, because everything within these two guys here is that's called metadata. We can also let me go here. I usually, if I have metadata, I always, and I tap this one in, and I go like this, and new line. So this is how I would normally a nice clean one. And the same thing applies here. If we want to add a new entry, that could be float minimum 0.0. This makes no sense whatsoever, because this is a string, and a string can't have an actual value. But if this was a float value, we could set it to minimum 0, and you wouldn't be able to, it would stop the spinner to go below 0, because sometimes you have some effects that in the code produce nonce or errors, or if you work in derivative areas like normals, you get some unexpected results. It can be practical and fruitful to have to cap the possibility to go to certain values. Also, up, if you go up, if it's computation heavy stuff. So that was completely side railing, but this is a string widget called filename. And then OSL knows that it needs to pop in this value here, and that basically just ports us directly to a bitmap picking situation. So that's it. And if we can check that this is in effect working, so if I do like this, I would say that 25% of these tiles should be only rotated 45 degrees. Looks about right. So we can see that it's working. So so that was it for this one. A little bit of Osl coding here, Osl coding. So let's reset this guy here. Something like that. Okay. So I need. I think I need. I need to. I need to. I need to write something like this. I'll go somewhere else for 5 minutes, and I'll be back again in 5 minutes. Alright. So we're back. And since we don't have any questions so far, I thought about what should we do. I went out in the greenhouse, had a small pause there. So let's delete this one. Let's see what we can find out to do next. We have no questions. So let me go here. I just need to find something. I thought about something. Vegetation. Trees. Ash tree. What is this? Ash tree. Let's see here. Green ash. Let's try this one. I want to show you something. We have some kind of tree here. Let's look a little bit on this tree, and as you can see now, this tree has some different parts in it. That's very impractical when you work, for example, with scatterers. So let me collapse this thing here. Actually, no. Let me see how I best can do this. Let me go here, collapse it. Let me see if my thingy here is respected. Element. No. Let me take something else. Nope. Temp. Let me see here. Black low. Maybe I need to condense it into one. I actually think I need to do that. Let me go back again, try the ash tree. Something like this. Go up here, import. Reading the FBX. Still doing the same thing. So we need to go here. Match material IDs, condense them. Something like this. Let me see here. Element. I just picked all the elements. Deselect that one. That's a bit slow. Something like this. We're going to set a new ID for these. We set these to ID 2. This is just for illustrative purpose. I'm setting this up. This is always one of those things that when you haven't prepared it. So this is ID 1 and we have ID 2. Let me just quickly add a material to this. So now this tree is completely gray. Let's open Arnold here. So we have this nice tree here. Let me just check. Did the app crash? I'm not so sure. I'm not so sure why it's so slow. Let's see here. We have to wait a little bit. Okay, some huge lagging going on. There we go. Okay, so we have this tree here, and we have. Let's just pretend. This is a normal, nice tree, and normally when you work with something like this, you would automatically go to the multi-sub material. I haven't been using this one for a very long time. It's a very established way to work in 3D Studio Max. I don't like it. I have a different way to work, which works with one material and some index nodes instead, because you can get some very ugly noodles where the larger these things gets, and in certain cases, when I have to debug, people sometimes send me things to debug. They have a giant list here, and the tree is just exploding, and everything is connected, interconnected, and things they drop in and merge, and it's just horrible. It's horrible to debug on, and there's no. It's very easy when you sit as an end user to just merge materials, and these multi subs just keep rising. But I prefer to have an order structure laid out instead, and take the time it takes, and simply just don't use this, because we can get the same thing going with just one material instead of multi-sub. We can get the completely same thing going. So how do we do that? Well, we need to first identify. Why is this one not rendering? There's something wrong here. I think I need to take this guy here. There's something wrong. I think I need to restart. I hope I can select this one, because this is just a small tree. I hope. Oh, I can't. Can I? No, I can't. There's something that hung for me here. Something is not right for me here. Okay. Just too bad. This one, convert to. Oops. I saw a discussion somewhere where actually someone complained about what I actually just did right now. I converted it to a patch, and the guy didn't want mistakenly converting to patch, and that's actually what I did. So I'm going to close this one down. Just nuke it. Just die. Start over. That's what happens. So be it. But actually what I want to show you is how you can build a multi-sub with just one material and some nested control maps, and get the exact same thing. And that means all your normal maps, all your diffuse maps are grouped together instead of laid out on all the separate materials. It will make it more easy to control and manage. Let's see here. Starting up. Where's my tree? I think I'm going to take another tree. oak, green ash, why not? Something like this. Import a single mesh. Import. I think this is more in line with what we actually want. Let's see here. This is a mesh. I'm going to move to polygon. It's a bit slow converting this. Never really found out why, but it's annoying. Element. Let's take polygon here. Let's just select ID1. So that appears to be branches and the main trunk here. Select ID2. That's all the leaves, I think. It's a little bit slow. 3D Studio Max develops could certainly speed up these things, because I mean, I'm just sitting here waiting. There's no reason for me to be sitting here waiting. Okay, so we have this one, and let's try and pop up the see what this is. Yeah, so this is typically what you have, what everybody's using, but instead of this, I'll do it in a different way. I'll show you how to do that. We just take one material like this, and let me go to Arnold here. System. I'm going to crack this one down here. Something like this. We have our little tree there. So that's fine. Something like this. Okay. So how do we get back to have control over the material IDs, and eventually I want to inject random IDs on the leaves, so we can yeah, just get some variation. So let's see here. We remember that the trunk and the branches was ID1 and the leaves were ID2. So I'm going to pull up some debug stuff here. So what we are interested in is this one. We don't need 2, 3. We actually only need 2. Let's go with red here. Let's go with green. These are coda colors. These are debug colors. There's no shame in using red, green, and blue. So we probe the the diffuse color first. Actually, I'm not going to use the diffuse. I'm going to use the emission. I'm going to close down the diffuse component and reflections, something like this, so we don't have any shadows or any fake stuff. We actually only get the true colors here. So we need some kind of driver for these two colors here, the red and the green. What should it be? Well, of course, it should be the material ID. we'll go something like this. 3D Studio Max viewport is broken on this account. You can see it down here, no conversion possible. Baked texture is used. We can actually also only see 4 material IDs in the Max viewport currently. So that's where it's nice to have Arnold here, because it shows exactly what we need or want. We have 2 IDs here. So we actually started to make a branch. We made 2 branches, and we want to inject some textures into these 2. So let me just go to, let me see here, import. Where was this? Vegetation, trees, green ash. Let me just go there. So that was vegetation. Let me see here, the models, vegetation. It was 01 trees, green ash there, and we have some bark, and we have some leaf stuff going. So we should be good to go. And instead of using the legacy bitmap, I'm using the Osl Bitmap here. Okay, it popped the same, it popped the right folder here. Convenient. So for now, I'm having this one on because we like to debug a little bit. We also need the leaf here. We could take the alpha here. We could take the normal map here. Something like this. Let me just remove these out here. Okay. So let's pipe the trunk material up. As you can see here, the viewport fails, so don't look at this, just look at this one. And as you can see here, we start to get something that looks like a multi-sub, just without the multi-sub. And we want to, I can go like this. We want to pick our diffuse texture here. And we want to pipe that into this guy here. And we start to see some diffuse textures here. And that's basically it. There's no more than that. We now, instead of making a multi-sub with 2 materials, 2 textures, we made a general driver, an array map, and diffuse components. So if you have more, you can add in more slots here and just pipe your bitmaps in there, and all the IDs will be respected. So that's kind of practical. But we also want some variation on these leaves. Let me go back to the diffuse component here. Let me crank up this guy here. So now we're back to a bit more. I'm not going to wire up the alpha map right now, but for the alpha map we would need to make a new array down on the cutout here. I'm just focusing on the diffuse component here. So this tree here needs some additional info for all these leaves. And I'm going to close this one down. So we pick the tree here. Let me save this one. We call it fantastic tree. Something like this. We need to do a little bit of processing on this tree. So we pull up the data channel modifier here. We're going to add color elements. It's going to spin for a bit here. It's actually processing all the leaves and all the branches on the main trunk. This could be a great deal faster. It should be instant. Unfortunately, it is not, so we have to wait. This is a one-time process. Once it's done, we can get over with it, and Arnold will pick it up really fast. Oh, come on. It's not that big a tree, I think. It's just a standard tree. There we go. So it added the color elements, and we need to swap this one out from face to element. See, if you needed to do this 1,000 times and you had a very pressing deadline, this is where people starts to get pain out in the left arm and get hollow cheeked and lose appetite for life and stuff like that. So we clearly need the Autodesk developers to look at this because it's painfully slow. So so what is it that we attempt to do here? Well, let me just add the output here, something like this. Then we could close this window here. What are we trying to do? Well, we're trying to add some additional info that we can use inside our new custom way of handling the IDs. We want to address only this input, the input 1, because it's the leaves. We're not interested in the branches and the trunk down here. I also need to convert to sub-object type here. We have some guys outside running their scooters. So let's see here. Unfortunately, this is not my fault. It's just the application that is super slow. So we just have to bite the apple and accept it. So once this is added, I can close this guy down. I can pull this one up here. Once this calculation is done, we can collapse it and use it, and the whole thing will become fluid and fast again. We just have to wait. There's no way around it. Actually, think I want to say fantastic tree. And the position down here, I should have made a dummy scene instead of using an actual tree I can see here, because this is sucking time for people looking at it. Basically every move I do is extremely costly because it has to recalculate something. Actually, I hope someone from Autodesk is looking at this because it's painful. So you want the vertex channel type to be a map instead of position, so this should bring our tree back. Something like that. Vertex output. Okay, so this is going to take a little bit. I expect 7 minutes or so. So yeah, I guess the streams can also be a little bit about lags in the application as we go over them. I certainly would say that we're lagging speed in this scenario here. The data channel modifier is a nice concept, but the data structure and the bandwidth that the data is able to be streamed is I think under par, because we've been sitting here waiting for 5 minutes on really on nothing. Okay, so we need to pop this out to a map channel instead of a position. It's not going to take a lot longer time. I should have done these things before I enabled the color elements. The sequence does matter at the heavy calculation in the end. Something like this. We add it to channel 6 in this case. We don't need to name it anything. We just export it to channel 6. I use channel 6 just to illustrate how we fetch it, how we use it. And we need to go back to the color elements. I should actually disable this if I have before I worked with these two, but again it shouldn't be necessary. So we go back to the color elements and dial in the actual thing that we need. Come on. Give me some UI. Okay, so we want to take all the elements and we want to actually randomize those. We only need one parameter. It could be you can see here HLS. This is actually this is saturation, luminosity or light and hue. We're only going to use the L. It's actually the exposure. So we need 3 more clicks. One there. That was okay. We need to crank this one up to 100. This basically means that all elements in this tree receives a different, you can call it ID, a different color, a solid color. I really want to see the cursor start to blink. There, thank you. Delete 100. That's 100%. And let's wait and see. Hopefully this should be enough. We have a hole through. Yeah. So I'm going to declick here. Get out of this horrible update speed. I have already clicked in the viewport. And once we get back to Arnold, it'll be fast. We'll get our life back again. Phew. There we go. Okay. So let's see here. We start rendering. Nothing changed. All good, because we haven't done anything. Just saving this baby here. Fantastic tree. So finally we're back here. Tree is now loaded with random IDs on the leaves. I hope we don't have to go in. There's some setting I forgot. But for this we actually need another one of these 1 to n maps here. And instead of this this guy here, I'll just detach the bitmap. I'll input the this guy here, because we are now cascading or nesting a new type, and we need a new index. Obviously it isn't the material ID. We need to fetch this channel 6. We exit the data channel on channel 6. So we need this guy here. We need to go to 6. And since UVW is a vector construct, or a point which has 3 values in it, like a point po equals point x, y, and z. So the index actually only needs one component. So we go up here, we go within here, and we intercept the signal from this UVW, and we called it F UVW equals UVW 0, something like this. We just fetch the first channel of this channel 6 here, and we also need a new output here. Output float, because this is a float value. FUVW equals 0. Oh, we need a comma there as well. Something like this. You see we have a new slot down here. Something like this. And let's see here. Oh, okay. Actually, I just remember now that I stumbled into some fatal issue with this. Oh my god, I stumbled into a fatal issue with this some time ago and completely forgot it. But this is actually how you do it. Um, let's see here if we can trigger it. I need a range remapper here. Something like this. Let's see here. So I'm creating myself a debug situation. Red, everything is affected. Red, green, blue. Just checking. This is channel 6. Is it stored on channel 2 instead? It is stored on channel 2. Okay. So as you can see here, we now have a bunch of colored leaves, which is actually, let me just check if I can remove this. I can't. I actually need to go in here, and if we say 1, if we say 2, if we say 3, yes. So this is how you do it. This map here is, the tree is sending out the information in the space 0 to 1, and we need to amplify this range so it starts to catch these slots here. This is an array map. You can consider this as you can actually see it here: 0, 1, 2, 3, and 4. So we can start to catch those, and this is the output range. So if we only output 0 to 1, it will only fetch the red slot, 2, 3, and 4. And you can obviously quickly imagine that you can do something like this. You can swap out this one to this. You can color grade the next one here. Let's see here, twig levels, something like this. 2. We don't need that one. We need to look at this one. And we're going to lower the saturation, poke around with the hue here, and I'm going to delete these two, something like this. This is not great. We need to go the other direction, something like this. We could actually also go something like this. And as you can see here, we start to get variation in the leaves here. That's basically it. So I didn't enjoy this slow data channel thing a whole lot. I would have liked it to be a lot faster. We need to poke Autodesk, do something about it. But that's basically how you would do it. We have the material ID picking up the 2 slots, sending out two branches here, one for the trunk, one for the leaves. And actually the trunk is also part of the whole thing that we generated on this channel too. I actually didn't need to add the convert thing in the DCM and the vertex output. I could just have made the the initial DCM modifier and stick with that, because we're using the information from that. So that was my mistake. So we did a little bit of custom coding here. You can also use the no, not, sorry, 2 seconds. You can also use the component map here, something like this. This would be the same thing. I just coded it. And we split out. We focused in on the leaves here, and we made 2 different inputs. So we can actually also just take one bitmap and use the Arnold. Let's see here. We have the Arnold jitter node. We can pipe that in there and just one bitmap, and it will use the element color. So we can pipe just one map here and get a ton of variation in the colors here, instead of having to grade one of them each after each other. So as you can see here, the viewport is broken, but it's rendering correctly up here. So I wish that would have been a little bit faster to go through, but that's the general concept of it. And while you say, yeah, well, but you made a ton of maps here, and why is this better than multi-sub? Well, these maps can be coded down to just one map. So all this can go into just one map. So that's the main benefit of OSL. You can condense this down, and if you have something like speed tree always comes with, I don't know, 4, 5, 6 maps, and you can make we can program an OSL shader called speed tree, and it will just be one map, and we plug it up to one physical material, and the whole tree will be ready to be ready to render. And so that's it. I made a small script that automates this whole process. I have to blame this specific tree for being so abnormally slow, because once I normally just have a button up here, I press, and it generates the IDs and all that, and it only takes 5-10 seconds or something for everything. So I don't know if it's the UI or what it is, but yeah. So this is the main concept, and we can condense all this down to just one map. We can't, of course, do that with a multi-sub. For a multi-sub, you would need the multi-sub, you would need 2 materials, and you would need bitmaps, and you quickly have 7, 8, 9, 10 nodes. With OSL, we can do it all with a physical material and just one OSL node. So that could be something that we look at in the future. I can expose this to the Rebel pack. We have that up here. We could expose that. So let's see here. What do we have? 2 hours and 9 minutes. So I think today we actually managed to get 0 questions. So that's fine. I will pick up next Friday. I will. I threatened in last live session that I wanted to do some PBR. I actually also got some good ideas from a guy on Discord. We could work with Max Hair and Fur, how to do cow skin. We could program or use some of SAP's maps to make cow skin, and then do an actual cow skin with the Arnold hair material, which we have down here. Show how you can control the colors with some OSL code or bitmap. And this guy also asked about a round trip around the Arnold AOVs. Maybe how to which should be used in normal shading or in normal compositing, and which are beneficial for debugging. Something like the C, I often see that people that use the C component here says, well, it's always white, completely white. Why is it always white? It's because the Arnold, as you can see here, it's because it's out of range, out of visible range. But in your post application, you'll just simply lower the exposure on it, and your little scene will come up in the CPass. So one thing that is good to use when using I imagine we could do some Arnold exterior, maybe interior rendering next Friday, and we could use this AA inverse density to kind of look at some of the information that is returned and analyze it and use it to our advantage to calibrate something like the adaptive threshold, max samples and bottom samples. He actually also asked that we maybe go through what are all these settings, what are all this, what is this, filtering. This is a very powerful section here when you do work with high intensity lights. You can remove fire clamps before you use denoisers and significantly reduce your render, and it will not destroy the it will remove some of the HDRI information in the image, but you can still perfectly create very nice highlights in post with values around 1. These values are in general very fast, and so something like that we could go over TX. We could look at OSL blur mechanisms there. So I think we have some topics we could look at for the next sessions. So that's always something we can look at. There's we could also look at Material X files, for example, how to export those. What is the looks? We could look at some properties on these Material X files, and we could go into the Arnold. We could start a little bit to look at the Arnold operator graph here. What does it take to load a Material X file? And I should actually, there's a direct connection between the look here, and you can actually, this drop down when we load a Material X file, if the file has multiple looks, you will access them through this drop down. So that means we can make a quick material that's called AO or normals or point position or some complex shader or a variant of it, and we can quickly go in here and just pick those, and it will populate to all the nodes that we basically reference up here. So maybe we could go around something like this as well in the future. So I think that's it. I'll ask my girlfriend if she wants to have something to eat. because we're quite hungry and it's 2011. So that's it. That's it for now. There's a little bit of technical things. Ideally, I think I want to also produce some eye candy, something that looks really good. Because one thing, and then go through how to make that piece. It could be volume procedures, it could be architectural interiors, it could be exteriors, um, it could be any number of things. But I think it would be really good to really dig in deep on some of the how to on a nice, for example, on a nice architectural interior. But that requires me to actually produce it. So we'll have to see when I get motivated to do that. When that happens. Um, so we'll see what the next session brings up. But we could do something for hair and fur and AOVs. Get a little bit more into actual Arnold rendering, using the UIs and stuff like this. Because yes, we can do a lot of small tricks and tips. That's fine, but I also think that would be nice to just see a really nice image rendered. We could also do some compositing cars on photographs. We could do some 3D scanning, and we could composite the tracking stuff, how to solve those things. We could also bring in some plugins like Tyflow. There's all kinds of things we could do. So, but here in the start, we just go with the basics, and we evolve as time passes on. So I think this concludes the August 14th stream. And I wish everybody a very nice evening, day, and morning, wherever you are. Have a nice one. Bye bye.